All right. So if component form was at the very beginning of the chapter, that was, we first talked about actually bearings and all of that. So understanding what those mean. Component form is in section 2, page 492, is where it starts. Magnitude is page 493. So all of those back into it, which we used a little bit in section 1, but this is kind of where we introduced this terminology. So component form is really simple. You're really just going to subtract. So you're going to do your ending minus your beginning here. So to do it in component form, you're going to say -8 minus a -1. And then you're going to say 1 minus 3. And so your component form is going to be -7, -2. So that's the first answer that you get here, -7, -2. Oh, no. All right, then it wants magnitude. You're going to take those and you are going to do your square root of the sum. So you're going to say -7 squared plus -2 squared. You're going to the square root of 53. They just round 2 decimal places for me. So that is going to be approximately 7.28.
You don't want us to leave it in the square root?
The last thing it wants is the degrees. So we're looking for direction. You have your x and your y. So you can always use tangent here. So we're going to do the inverse tangent of y divided by x. All right. Now you have to think about what quadrant you're in. I am -x, -y. What quadrant? I'm in the third quadrant, right? Which means it's going to give me the degrees up to my x when I do that. All right. If I were to take this and say, okay, I just want to do the second tangent of 2 divided by 7, then I am going to get 15.9 degrees here, put 15.95 specifically, all right? But what you have to understand is that it has given you this piece of it, and you want all the way around to this. So you have to add this to 180, all right? So you have to take 180, and you have to add 15.95. So you should get 195.95 degrees here. So think about what quadrant you're in when you give me that final answer. And those are your 3 answers. This second set of problems is identical to what we just did. I mean, it really is. Component form, you're going to subtract these 2, right? So you're going to say -1 minus a -9 to give you a +8. And then you're going to say 4 minus 8 to give you a -4. Okay? So we're at +x, -y. You can see that if I were to just slide this guy down to the origin, he would be in the 4th quadrant. Like, you can obviously see that based on how he's the direction. And remember, they're parallel. The one that I had originally and where I slid him is parallel. So even if you didn't do that, based on this answer, you can see he's going to be in the 4th quadrant. +x, -y, right? My magnitude is the same. I'm going to say 8 squared plus -4 squared, and I'm going to get 8.94. All right? And my tangent, I work exactly the same. The inverse tangent of my y over my x. And you don't have to put the negatives in there, by the way, because it's always going to do it in negative angular form here for tangent. So you can just say 4 divided by 8. And you're going to get the 26.56 degrees or whatever it is. Now, again, you have to consider what it has told you. All right. So you have to consider that it has told you from that to the horizontal. All right, so that is going to be the angle here. We want all the way around, all right? So you can either add that to, there's a lot of confusion if you use your 270. The easiest thing is when it's in fourth quadrant, subtract from 360, right? So I'm going to take 360 minus my 26.57. And you're going to get your 333.43. And that is your answer here. So we have two things happening. Nancy and Harry are sliding a stone statue and moving it to a new location in their garden. Nancy is pushing the statue with a force of 120 newtons at a 60-degree angle to the horizontal. Harry's pulling the statue with a force of 180 newtons at a 40-degree angle with the horizontal. What is the magnitude, and we did not space there, of the horizontal force exerted on the statue? Exerted on the statue, okay? Everybody understand what's happening here, all right? So the first one, all right, she is pushing. She's pushing. Where is the 120 going to go? On the hypotenuse, right? All right, so it's going to be here. This is 120. To the horizontal is 60 degrees, all right? So what's my x and y? How do I find it?
The sine of 60
Right, that's my,
times 120. And then
that's my y value. So my x value is going to be,
cosine of 60.
so 120 times the cosine of 60. All right, that's my x value. 120 times the sine of 60. All right. What do you get when you do that?
For cosine, it's just 60.
So for cosine, you get just 60, right?
And then for sine, that's what I got too.
I got 0.92.
Okay.
I just wrote.
All right. Imagine what's happening. She's pushing this way, correct? So her motion is pushing up on the y value and up on the x value, right? Does that make sense?
The x value is still positive, but the y is just
Right. He's pulling, right? He's pulling. So he's going to be, your x is still getting larger as he pulls, but if he's pulling, right, what's happening? My y value is being pulled against.
So it's 40 degrees this way.
Right, so it's 40 degrees. So when we draw this guy, that's why I said he's a little bit of a different one. When I draw this guy, I have to consider the fact that he's pulling. He's pulling it, not pushing.
Okay.
Does everybody understand why pulling is going to make that motion? It's not going to take my x negative because he would have to actually be pushing against her to do that. So they would have to be pushing this way and pushing this way for what your scenario, pushing against the x and against the y.
Yeah.
He would have to be pushing in the opposite direction, which would be useless in moving the statue, right? So this is what we're doing.
Okay, then I just put my angle in.
Gotcha. So pulling to the horizontal. So you're still pulling to the horizontal, but think of it as like a negative angle. All right, so once again, this guy is 40 degrees, all right? So we're gonna say 40 times, not 40, how many newtons is he using? 180, so we're gonna say 180 cosine of 40 and 180 sine of 40. And what do we get when we do that?
For cosine's 137.89.
For sine?
For sine, it's 115.7.
But what are we going to have to consider here for sine? It's negative. All right. Component form here. Component form is going to help us. Actually, we don't even have to go to angle, right? And when we answer this final question, if you look, they actually just want the magnitude of the force, don't they? So we just need to find component form and do magnitude. We don't even have to worry about angle here. If they wanted direction for some reason, then we would do angle. But they're not even asking for direction.
So
They're
we
just
have
asking for magnitude.
The hypotenuse of the new triangle.
Correct. So you're just going to have to add your 2 x's. Get your 197. That's your new x. Get your new y. And then take your magnitude of that. Well, that makes me feel better. So they did mean exactly what we thought they meant. That makes me feel better. And yeah, when I do this, because I rounded within the process, their answer probably did not. I got 198.2,
Yes.
but I rounded within the process, which is fine. And this is newtons, by the way. It's because we rounded here when we rounded there. So if you had put in 120 cosine of 60 plus 180 cosine of 40,
It would have gone different.
right, and done the square root of that, but that's a lot to put into your calculator at one time. So I would actually rather you write it out and round it within the process and show me than to not.
You can say pulling 3
So you would say
degrees.
pulling 3.4 degrees to the horizontal. You could word it exactly the same way.
Do you have to write anything for the newtons, or can you just say 198.2 newtons?
No, this is the magnitude. That's all you have to say.
Okay.
If it's just asking for the force, they're not asking for whether it's,
So you would only have to write something out
if they
asking
ask for direction. Direction is what you're looking for. But yeah, you do need to think about what quadrant you're in and how they gave it to you. If they gave it to you in a true bearing, give me the answer in true bearing. If they gave it to you northeast, give it to me northeast. Right. Questions on dot product. These you just need to know. Dot product, and I think these are on like page 500, somewhere in that. Dot product is just your x's of each one. So your x of your first one, your x of your second one, and then you're going to add to it your y's of your first times your y's of your second. Helps to write the word y of your first one, y of your second one. All right? I'm not going to make you tell me parallel, but I am going to tell orthogonal or not. How do you know if they're orthogonal? If that dot product equals 0, it's orthogonal. If it does not equal 0, it's not. Okay? You don't have to worry about parallel. Then how do I find the angle between the two vectors? How do I find the angle between the two vectors? Right, so that's my inverse, right? Cosine, right? Of my dot product. That's my dot product over what? My magnitudes multiplied together. All right, magnitudes multiplied together. Yes?
Then do you multiply it by the...
No, that's you're moving on to projection. Mm-hmm.
Magnitude is
Can you do that?
X squared plus the y squared. Mm-hmm. Can I? All right, so for this one,
Where's the bottom?
okay, so the dot product is just what we did up there. 4 times -1 plus 6 times 2, right? 4 times -1 plus 6 times 2. That's my dot product. My two magnitudes, that's going to be 4 squared plus 6 squared under the root times -1 squared plus 2 squared under the root. Magnitude is just what we found like on the first page. That's just the notation for magnitude.
In the word...
Projection is on page 503. And that's your dot product over your magnitude squared times your vector that's being projected onto. And that's what you're going to use for that and your word problems with force. Remember, you're just 1,780 is 0, negative 1780. Right.
And you have